Bright Cutie. Every student matters.
Hello students, my name is Sanjay Jain. In the previous exercises of quadratic equations, we have learned about how to recognize an equation as a quadratic equation and then solve it by various methods. One of the methods was using the quadratic formula directly, and when we derived the quadratic formula, we defined a term discriminant, right, which was equal to b square minus 4ac. Now based on the value of that discriminant, we will see the nature of roots of the quadratic equation, right? So what was the discriminant? When we took the standard equation as ax square plus bx plus c equal to 0, where a was not equal to 0 and a, b, c were real numbers, right? We started our lecture with this equation. So what is discriminant? Discriminant d is equal to b square minus 4ac, right? What is b? B is coefficient of x, a is coefficient of x square, c is the constant term, right? And what was the quadratic formula? Quadratic formula for this standard equation was x equal to minus b plus minus root of b square minus 4ac divided by 2a, right? Then we wrote it as minus b plus minus root d divided by 2a, right? And what is this quadratic formula? This gives us the value of x. And what is the value of x in a quadratic equation? It is the solution or the root of that quadratic equation, right? So this plus minus sign gives us two different values, right? So x is equal to minus b plus root d by 2a or minus b minus root d by 2a. Okay, so these are the roots that this quadratic formula is giving us. Okay, now we need to discuss the nature of these roots depending on the values of d. Okay, so let's see. First of all, these are my two roots, right? Let's see these are distinct or equal, whether these are real, unreal, or what. If I take d equal to 0, what will this value become? This value will become as, if I take d 0 here, it will become minus b by 2a. Similarly, if I take d 0 here, it will become minus b by 2a, right? Both the roots will become equal and equal to minus b by 2a, right? So case number 1, when discriminant d is equal to 0, a quadratic equation will have equal roots and the roots will be equal to minus b by 2a, minus b by 2a, right? And let us see when d is greater than 0. When d is greater than 0, the roots are minus b plus root d by 2a, minus b minus root d by 2a, right? If d is greater than 0, then obviously minus b plus root d will be distinct from minus b minus root d, right? D is positive, so let's say d is 5, okay? Minus b plus root 5 and minus b minus root 5. These are two distinct values, right? When d is greater than 0, we will have two real and distinct roots, real and distinct roots. Okay, let us see when d is less than 0. When d is less than 0, minus b plus root d by 2a, minus b minus root d by 2a. What will happen when d is less than 0? There will be a negative sign inside the radical sign, right? When there is something negative in this sign, radical sign, this value is non-real. This is not defined in real numbers. This is an imaginary value, right? So if d is negative, we will have no real roots. No real roots, or we can say we will have imaginary roots, right? So this is about the nature of roots in brief. We can also define the roots as rational or irrational roots. Let us see when we will have rational or irrational roots. Okay, the roots are minus b plus root d by 2a and minus b minus root d by 2a, right? So to make these terms irrational, only this root d will make a difference, right? If there is a perfect square inside this radical sign, let us say there is a 4 inside it, so it will give us 2, right? Then this entire term will become rational, right? If let us say there is 5 inside, so this cannot be solved, it will remain irrational, right? You cannot bring anything outside, there will always be root 5 in this expression, so it will make it irrational. So if d is perfect square, then the roots are rational. If d is not a perfect square, then the roots are irrational. And you should notice when the roots are irrational, let us say d is root 5, okay, minus b plus root 5 by 2a minus b minus root 5 by 2a. Then the only difference in these two roots is this sign, right? So let us say one root is 3 minus root 5, the other root will be 3 plus root 5. Okay, one root is root 7 minus 3, then the other root will be minus root 7 minus 3, right? Only the sign of this irrational number is changing. Okay, so we call such roots as conjugates also. Okay, so in brief, we can say when the d is not a perfect square, we will have irrational roots, and those irrational roots will be in conjugate pairs. Okay, we just need to take care that the sign of irrational part will change. Okay, so this was about nature of roots.